Hey viewers, this is Devinder Kaur and welcome to my YouTube channel, The Enlightened Room. In this video, we're going to talk about the electronic configuration of elements in the modern periodic table. So let's get started. So first we're going to start with the groups. So in the groups, as you can see, all the elements of any group of the periodic table would have similar, or you can say identical, valence shell electronic configuration. However, as we go down the group, the number of filled shells increases, but the pattern of the electronic configuration remains the same. As you all can see here clearly, you can take the example, or you can consider the electronic configuration of elements of group 1. As you can see, these elements have one electron in the valence shell, but the number of filled shells increases from 1 in lithium, 2 in sodium, 3 in potassium, and so on, as you can see here. Similarly, all the elements in the group 17, as you can see here, have 7 electrons in the valence shell, while the number of filled shells increases from 1 in fluorine, 2 in chlorine, 3 in bromine, and so on. Further, as we know that the properties of any element depend upon its valence shell electronic configuration, so all elements in a group will have similar properties. Why? Because they have identical valence shell electronic configuration. One more thing to be noted is that elements in a group do not have consecutive atomic numbers, but they are separated by a definite gaps of atomic numbers. And what these gaps are: 8, 8, 18, 18 and 32. Well, there is an exception here for group 1. Now what this exception is, they are separated by gaps of atomic numbers of 2, 8, 8, 18, 18, 32. Now you can take the example here. The atomic number of elements of group 1 are 1 for hydrogen, 3 for lithium, 11 for sodium, 19 for potassium, 37 for rubidium, 55 for cesium, and 88 for francium. So it can be said that the atomic numbers after which the properties of the elements gets repeated are 2, 8, 8, 18, 18 and 32. That means we're going to subtract these atomic numbers. So these numbers 2, 8, 8, 18, 18, 32, after which the properties of elements get repeated, are known as magic numbers. So now let's talk about the periods. Now in this, we're going to consider the electronic configuration of elements of second and third period. Okay. So as you can see clearly from this image here, as in the period we go from left to right, in the second period we are going from lithium to neon. So in this, the number of valence electrons increases by 1 unit from 1 to 8, as the atomic number increases by 1 unit from 3 to 10. So the number of shells containing electrons remain the same, but as you can see, the atoms of different elements with the same number of occupied shells are placed in the same period. Now you can take the example here as lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. These all belong to the second period of the modern periodic table, since the electrons in the atoms of these elements are present in 2 shells. Now what these shells are? K shell and L shell. Similarly, in the third period we take the elements sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Now as you can see clearly here, the atoms of these elements are present in 3 shells, that is K shell, L shell and M shell. So it should be noted here that each period starts with the filling of electrons in a new electronic shell. That means you can again take the example of second period, L shell is being filled. In the third period, M shell is being filled. In the fourth period, N shell will be filled, and so on. So we're going to note here, the important thing that should be noted here is that elements in a period will have consecutive atomic numbers. For example, elements of second period have consecutive atomic numbers from 3 to 10, while those in third would have consecutive atomic numbers from 11 to 18, and so on. So this was up for today's topic, electronic configuration of elements in the modern periodic table. For more videos like this, subscribe to my channel and click on the bell icon. Thank you so much.